If you were told that China launched a rocket ship that got to the edge of space, separated, returned back to Earth, and got scooped up by a recovery ship like a giant mechanical fisherman catching a falling skyscraper, you'd probably ask for the title of the sci-fi movie. But this is not a movie. On the 11th of February 2026, China pulled off this rocket test that looked more like a SpaceX highlight reel than anything we've seen from a government space agency. Because China is no longer talking about going to the moon. They're actively building the system that will take humans there before NASA and SpaceX can do it again. Just days ago, at the Wenchang Space Launch Center in Hainan, engineers rolled out a brand new rocket, Long March 10A. This is China's lunar workhorse. Sitting on top was a new crew capsule called Mengzhou, literally translated as Dream Vessel. And what they tested wasn't a normal launch. It was something far more extreme. 5 engines ignited. The rocket thundered upward, slicing through dense air, accelerating toward supersonic speed. The spacecraft experienced Max Q, the moment when aerodynamic stress is at its absolute peak. It's the point where rockets are most likely to fail, and that's exactly when China triggered the abort system. Imagine riding a rocket exploding upward at thousands of kilometers per hour and suddenly detonating a second rocket on top to rip the crew capsule away. That's what happened. The escape system blasted Mengzhou free while the booster was still firing. The capsule tumbled, stabilized itself, deployed parachutes, and splashed down safely in the ocean. That alone would be a major milestone. But the booster? It didn't just fall into the sea. It throttled down, reoriented, deployed grid fins, reignited engines, and guided itself toward a controlled descent. Waiting below was a recovery ship with a massive net system designed to catch future boosters mid-air. This single test demonstrated launch, abort, guidance, booster recovery, ocean operations, and next-generation reusable rocket technology on hardware that had never flown before. This is way past experimentation, it's pure execution. And the reason this matters is bigger than rockets. China isn't copying Apollo. They're rewriting the blueprint for lunar exploration. Back in the 1960s, NASA built the Saturn V, a monster of a rocket that could throw 130 tons into orbit. It worked, but every launch burned billions of dollars. Everything was disposable. The command module splashed down and was retired. The lunar lander was left on the moon and the rocket stages fell into the ocean. It was a sprint fueled by Cold War politics. China looked at that model and decided it was unsustainable. Instead of one gigantic disposable rocket, they're using a dual-launch architecture with partially reusable boosters. Instead of one massive launch carrying everything, they're sending the crew and lander separately and assembling the mission in lunar orbit. This approach is cheaper, more scalable, and more aligned with long-term lunar presence. Here's how their mission actually works. 2 Long March 10 rockets launch within a short window. One carries the Mengzhou crew capsule with 3 astronauts. The other carries a lunar lander called Lanyue, which translates to embracing the moon. Both spacecraft travel on a translunar trajectory, arriving in lunar orbit independently. Then comes one of the most dangerous maneuvers in spaceflight, rendezvous and docking around the moon. This isn't Earth orbit. There's no GPS, no rapid rescue. If something fails, the crew is alone. After docking, 2 astronauts transfer into the lander. The third stays behind in orbit. The lander undocks and begins its descent. No atmosphere or parachutes. Only rocket engines slowing it down as it searches for a safe landing site among craters and rocks. One wrong calculation, and you impact the surface at hundreds of kilometers per hour. If they land successfully, the astronauts step onto the moon, something no human has done since 1972. They'll deploy experiments, collect samples, test technology, and potentially use a rover to explore farther from the lander. When the mission is complete, the lander blasts off from the moon and chases the orbiting capsule. Another docking, another transfer. Then the crew capsule fires its engines for the journey home. Re-entry is brutal. Coming back from the moon means hitting Earth's atmosphere at around 11 kilometers per second, fast enough to melt steel. Mengzhou will use skip re-entry, bouncing off the atmosphere to bleed off speed and heat before parachuting into the ocean for recovery. If all of that works, China becomes the second nation in history to land humans on the moon. And this isn't theory. The hardware is real. Long March 10 is designed to deliver roughly 27 tons toward the moon. Its engines burn kerosene and liquid oxygen, offering high thrust with manageable costs. What makes it unique is the reuse strategy. China wants to recover major components, something never done for lunar missions before. Mengzhou is China's next-generation crew vehicle. For Earth orbit missions, it can carry up to 7 astronauts, more than Apollo, and even more than the space shuttle's typical crew. For lunar missions, it's configured for 3, with expanded life support, navigation systems, and heat shielding. The abort system tested recently is smarter than previous designs. It doesn't just blast the capsule away. It actively stabilizes, reorients, and prepares for descent autonomously. That kind of automation can mean the difference between survival and disaster. Then there's Lanyue, the lunar lander. It must survive temperatures ranging from scorching sunlight to deep space cold, withstand abrasive lunar dust, and land on uneven terrain. China has already tested autonomous landing algorithms using simulated lunar gravity and artificial craters. The lander can scan terrain in real time and divert to safer locations mid-descent. Add lunar spacesuits, rovers, and surface systems, and you're looking at a full exploration architecture, not just a flag-planting mission. What makes this even more significant is the timeline. China isn't saying someday, they're saying 2030, and they're hitting milestones fast. Engine tests, pad abort tests, full rocket flight tests, recovery ship deployment, and landing simulations. This is a coordinated campaign with measurable progress. Meanwhile, NASA's Artemis program has faced delays, budget overruns, and technical hurdles. SpaceX's Starship is revolutionary but still in testing, with many engineering challenges left. Other nations are years behind. China, quietly and methodically, is building a lunar transportation system, and history suggests they'll deliver. When China said they'd build a space station, they did. When they said they'd land a rover on the far side of the moon, they did. When they said they'd return lunar samples, they did. Their pattern is simple: announce, build, test, execute.
And our first clue, our first vision of this, was actually presentations that proposed missions using a massive rocket which they called the Long March 9. And this would be a 4,000-ton rocket using methalox as a propellant. But it seems that that concept was simply too ambitious right now, and they've chosen a smaller evolution, the Long March 10.
Between now and 2030, expect an avalanche of tests, abort scenarios, docking demos, landing rehearsals, integration flights. Each test reduces uncertainty. Each success moves the moon from ambition to inevitability. And here's the bigger picture most people miss. Apollo was a sprint, but China is building a marathon infrastructure. Reusable rockets mean repeated missions become affordable. Modular architecture means upgrades are possible. Regular lunar missions mean research bases, resource extraction, and deep space staging become realistic. The moon stops being a destination, it becomes an outpost. In 5 years, we could watch humans walk on the moon again, this time speaking Mandarin, wearing next-gen suits, stepping out of a spacecraft designed for long-term exploration rather than a one-time stunt. And when that happens, it won't just be a Chinese achievement. It will be a reminder that humanity is still capable of giant leaps. But this isn't just about who plants the next flag on lunar soil. This is about who controls the next frontier of human civilization, because the moon is a strategic high ground. For decades, the moon was treated like a historical monument, a place we visited, photographed, and left behind. But today, space agencies and private companies are seeing it differently. The moon is a fuel depot, a science lab, a military vantage point, a stepping stone to Mars. And China knows this. That's why their lunar plans don't end with footprints. They end with infrastructure. China and Russia have already proposed the International Lunar Research Station, a permanent base near the moon's south pole. Unlike the Apollo landing sites near the equator, the South Pole is special. Some craters there never see sunlight, trapping ice for billions of years. That ice can be turned into drinking water, breathable oxygen, and rocket fuel. Whoever controls that resource controls deep space travel economics. Instead of launching fuel from Earth, where gravity makes everything brutally expensive, you refuel on the Moon and launch from a gravity well that's 6 times weaker. That changes everything. It turns Mars from a distant dream into a reachable destination. Now imagine this scenario. China lands astronauts in 2030. They establish a semi-permanent base in the 2030s. By the 2040s, they're mining water, producing fuel, and launching missions to Mars. At that point, they become a multi-planetary logistics empire. Meanwhile, NASA's Artemis program is still finding its footing. Artemis 1 was uncrewed. Artemis 2 will carry astronauts around the Moon, but not land. Artemis 3 aims to land humans again, but delays and funding uncertainties loom. Every year that slips gives competitors more room. SpaceX's Starship is the wild card. If it succeeds, it could revolutionize access to space. Fully reusable, massive payload capacity, rapid launch cadence. But Starship is still experimental. Rockets explode, timelines shift, engineering realities hit hard. China, on the other hand, is not chasing revolutionary leaps. They're chasing relentless reliability, incremental progress, tightly controlled programs, government-backed funding, and that's often how long-term dominance is built. There's also a political dimension that's impossible to ignore.
中国政府对中美航天交流合作持开放态度。
The Artemis Accords, led by the United States, are a framework for peaceful lunar exploration and resource sharing. China is not part of it. Instead, they're building their own coalition with countries across Asia, Africa, and Europe. So the Moon could become the next geopolitical chessboard. 2 visions for humanity's expansion into space, one driven by private industry and international agreements, the other driven by state-led mega projects and strategic planning. And history tells us that when frontiers open, competition follows. But beyond politics, there's something deeply human about this moment. For most of human history, the Moon was a symbol, calendar, or mythological object. Then, for a brief window in the 20th century, it became a destination. 12 men walked on its surface, and then we stopped. For half a century, the Moon felt frozen in time. Now it's waking up again. China's program is part of a broader resurgence in lunar exploration. India has landed near the South Pole. Japan is developing precision landing systems. Europe is planning robotic missions. Private companies are proposing lunar habitats and mining operations. We're entering the second lunar age. But unlike Apollo, this isn't about proving technological superiority for a TV audience. This is about building an off-world economy. Think about what that means. Manufacturing in microgravity, mining asteroids and the Moon, scientific experiments impossible on Earth, tourism beyond low Earth orbit. The Moon could become humanity's first true off-world settlement hub. And China wants to be there first, with boots, bases, and infrastructure. The recent Long March 10A test wasn't just a rocket launch, it was a statement. We are ready. The abort test showed crew safety. The booster recovery showed reusability ambitions. The mission architecture showed long-term planning. They're ticking boxes that took NASA decades to master. And they're doing it in a fraction of the time. Some experts believe China could even accelerate their timeline. 2030 is the official target, but internal roadmaps suggest earlier demonstration missions. Uncrewed landers, cargo delivery tests, and robotic base modules could arrive before humans ever step foot there again. By the time astronauts arrive, the infrastructure might already be waiting. Imagine landing on the Moon and walking into a pre-deployed habitat module with power systems, communication relays, and scientific instruments already operational. That's exactly how modern exploration is planned. And here's the twist. The real race isn't between flags, it's between philosophies. Do we treat the Moon as a shared scientific commons, or as a strategic resource to be controlled? China's centralized model allows them to move fast and commit massive resources. Western democracies move slower, constrained by budgets, politics, and public opinion. Private companies innovate rapidly but depend on funding and regulatory approval. The outcome will shape humanity's expansion beyond Earth for the next century. If China succeeds first, they could set the standards. Communication protocols, navigation systems, lunar traffic rules, resource extraction guidelines. The first major power on the moon doesn't just get prestige, they get influence, and that influence will ripple outward, to Mars, to asteroids, to deep space. But there's also a hopeful side to this competition. Every major space race in history accelerated technology. Satellites, computers, materials, science, medicine. A renewed lunar race could drive breakthroughs in energy, robotics, AI, and life support systems that benefit everyone on Earth. Competition can be a catalyst, so when you see footage of a Chinese rocket aborting mid-flight and a booster being caught at sea, don't think of it as a single test. Think of it as a chapter in a much bigger story. Humanity is returning to the moon, and this time, we're not just visiting, we're staying. Whether it's Chinese taikonauts, American astronauts, private explorers, or international crews, the moon is about to become busy again. And decades from now, historians might look back at these tests, the quiet engine firings, the abort simulations, the recovery ship waiting in the ocean, and say, that's when the second space age truly began.